Hey everybody, my name is Ross Bernet, and I'm excited to be presenting today about OpenStreetMap and the UN Sustainable Development Goals. And I'm coming at you guys from Philadelphia, and yeah, it's a wild time, and it's exciting to be able to do these presentations remotely. So yeah, if you want to hit the slides, that'd be great. All right, so yeah, my name is Raster Foundry. I'm a project manager at a software company in Philadelphia called Azavea, and today I'm going to be giving you an intro to myself and Azavea, an overview of the UN Sustainable Development Goals, a deeper dive into one of the SDG indicators, 9.1.1, the technical approach that we took, the opportunities, challenges, and the next steps with that, and then leave some time for questions. So Azavea is a 60-person mission-driven software company that specializes in geospatial data analysis and the development of custom web applications. Our mission is to advance the state of the art in geospatial technology and apply it for civic, social, and environmental impact. Some of the ways that we are advancing the state of the art in geospatial technology is our R&D into machine learning, imagery processing, and big data. We do a summer fellowship that pairs students with nonprofits in terms of civic, social, environmental impact, and we have project selection guidelines for working on projects that align with our mission. This mission is what attracted me to Azavea and a talented group of really passionate colleagues. It's a really, really great place to work. So a little bit about me. I went to the Yale School of Forestry to do my master's degree, and I think what really changed the course of my life was geospatial processing. I remember very distinctly the day that I learned about Google Earth Engine. It's a tool for bringing together massive quantities of Earth observation, imagery, and other data sets that allows us to kind of track what's going on our planet at this global scale. I've been excited about large-scale geospatial processing for, I guess, going on 7 or 8 years now. And the talk that I'm giving right now, I gave a similar version at a conference called State of the Map and FOSS4G, that's the free and open source conference for geospatial. And it's always great to give a similar talk to different audiences to learn about, to kind of go deeper into the subject, get different feedback, because the talk crosses a bunch of domains. So what are the Sustainable Development Goals? The Sustainable Development Goals are an ambitious set of 17 different goals created by the 193 member states of the United Nations in 2015. They're a blueprint to achieve a better and more sustainable future for all. It's these very ambitious goals like ending poverty, getting rid of hunger, ending climate change. Goals that are so ambitious in scope that some people actually criticize them for being too broad. The way that I see it is it's helpful to at least have a goalpost. Where do we want to be? What is our ideal future? And the SDGs provide a framework for actually measuring these things. So what does it mean to end poverty? Like, how do we define that? How do we measure progress? The SDGs provide a tool for doing so. So there are 17 different goals. Each of the goals has between 1 and 3 targets. And then each of those targets has between 1 and 7 indicators. And so the indicators are actually a quantitative measure of progress towards those goals. And this is a helpful way to track progress over time. So as a geospatial software company, Azavea is really interested in understanding the different geospatial aspects of the Sustainable Development Goals. Some of the goals are less geospatial in nature. For example, improving the reading rate. There's not necessarily a geospatial component in monitoring that, but a report created by Geo, the group on Earth observation, came up with an analysis of the different SDGs that have a geospatial component. And they identified over 50 indicators and targets that have a heavy geospatial component. Many of the SDGs have this concept of a proportion of a population that may have access to a resource or who has made progress on XYZ indicator. And so this report was a helpful place for us to start looking into how we could get engaged in the SDGs. All of the SDGs require data. data to measure and monitor progress over time. And so Azavea has a preference for using open source data, open source tools, and a data set that we've been working with increasingly in recent years is a data set called OpenStreetMap. Here's this possibly jarring GIF that I recorded that I really found compelling, that shows the kind of growth of OpenStreetMap over time in Africa. OpenStreetMap was started in 2004, and it's kind of like the Wikipedia of maps. Anyone can edit and contribute to it. And in many places around the world, it's actually the most accurate, feature-rich data set available. In some cases, volunteers are looking at imagery and tracing lines and buildings for data that otherwise just would not exist. This is helpful for disaster response and for monitoring progress like the STDs. There's over 6 million registered users of OpenStreetMap and 3.5 million map edits per day. This is pretty mind-boggling to me. And it's only continuing to grow. So I'm going to go through 4 different SDGs indicators, and just to give a sense of what do they look like, how are they broken down, how would you think about measuring them, and how OpenStreetMap might be able to help. The first one I'll talk about is SDG 6.2.1. This is the proportion of a population using safely managed sanitation services, including hand washing facility with soap and water. So particularly during this time of COVID, we are presently June 5th, 2020, and we are in the midst of a COVID response globally. When people are washing their hands 25 times per day, some of us might take for granted this access to being able to wash our hands. Access is not evenly distributed around the world. And sanitation services, hand washing stations can be mapped on OpenStreetMap for places where it's an issue to help understand where it might be helpful to have more. Another SDG indicator that I'm a fan of is 11.7.1. This is the average share of the built-up area of cities that is open space. So this is recognizing that green space and open space is good for people's mental health and is not evenly distributed. It's definitely a social justice, environmental issue of access to park services. So this is a measure of that open space in cities that is open. Another indicator that I like is 15.1.2. So this is a proportion of important sites for terrestrial and freshwater biodiversity that are protected. So this is national parks, national forests. How are we protecting our resources, and how does that proportion change within a country, maybe by state, province, etc., and how does it compare across countries? We can sort of measure ourselves compared to other similar countries. And then the last one that I'm going to go deeper in is 9.1.1. This is the proportion of the rural population who live within 2 kilometers of an all-season road. So I'm going to break down this sort of nomenclature, 9.1.1. What does that really mean? Goal number 9 is to build resilient infrastructure and promote inclusive and sustainable industrialization and foster innovation. So what does that mean, or how might you measure it? Sounds good. We all want resilient infrastructure. We want it to be sustainable, but we don't really have a sense of how might you track or monitor that. So then the target, 9.1, is to develop quality, reliable, sustainable, resilient infrastructure for economic development, human well-being, and we want it to be affordable and equitable. And so this is a little more specific, but again, is still, you can't put a number on this. You may be able to give a grade, maybe, but kind of putting a number on this, like, yes, we're 50% of the way there, it's just not possible. So the indicator, the final level, is proportion of the rural population who live within 2 kilometers of an all-season road. Now this is quantifiable. We can say 50% of a country's population lives within 2 kilometers of an all-season road, or 80%, 90%, and kind of track progress over time. This is sort of working under the assumption that access to roads is a good thing. This is an assumption we should call into question. Access to roads can lead to deforestation, may spread disease. So there's always considerations to be made, and I think it's really important to be critical of this. But the pros of access to roads is this concept of access to services. So do we have access to hospitals? Do we have access to schools? Are rural farmers able to sell their food to markets? Countries are often see a disparity between wealth in cities and wealth in urban areas, or wealth in rural areas. So how are the SDGs being monitored now? We have this framework for measuring progress towards these big sustainability indicators, but what's the actual framework for measuring that? I'm going to walk through a couple of the kind of key pillars of monitoring these. So each of the indicators is assigned a tier that indicates whether the methodology is established, whether the data exists, whether there's an agreement, disagreement. So one could imagine that the methodology may not reflect every country's differences. So flat countries versus more mountainous countries may have different ideas about what road access is. How do you create indicators that kind of, how do you create methodologies that represent that indicator that are universally applicable? This is a pretty challenging concept, and having this tiered system helps organizers understand where are we on our agreement from the different perspectives on measuring these. Then there's the concept of a custodian agency. So these are agencies within the UN and groups like the World Bank, World Health Organization, FAO, that are responsible for gaining consensus on a methodology and working with countries to report on that data. There's 37 different agencies that are responsible for at least one SDG indicator. Then we have a concept of the National Statistic Office. So most countries have at least one NSO, and some countries it's spread between different organizations within different agencies within the federal government. But NSOs are responsible for reporting on statistics like trade, population, GDP, and in many countries around the world, calculating and measuring SDGs is just kind of thrown on top of all the rest of the work that they're already doing. And in some countries, you have groups that are specifically dedicated to the SDGs, and so these NSOs work with the custodian agencies. There are working groups, there are phone calls, there's conferences all dedicated to this. It's a whole entire world to dive into. And I think understanding kind of these three concepts helps understand how they're being monitored now. So how did Azavea get involved in this? Azavea created an open source tool called Raster Foundry that is funded by NASA and the Department of Energy. These are research grants from the SBIR program, and they are it's a collection of tools to make it easier to work with satellite imagery, both to access and do analysis. And a group at the UK Office of National Statistics saw our work on Raster Foundry and asked if we could include it in the UN Global Platform. This is a tool that the UN is making available to national statistic offices around the world to basically have access to big data processing and imagery analysis tools. And so in discussion with the UK ONS, we thought this would be great to do a pilot of an SDG that could be calculated in the UN Global Platform. And we realized that 9.1.1 is a really interesting, helpful, illustrative indicator to measure. It's because there's really only three main data sets that are required. We have roads, population, and rural boundaries. With those three data sets, you can actually calculate indicator for a country. And conveniently, there are three global data sets that correspond to each one of those needs. So OpenStreetMap has road data for the entire world. WorldPop is an organization that publishes population statistics for the entire world. And then GRUMP is the Global Rural Urban Mapping Project, and it has a methodology that delineates urban versus rural boundaries and is available globally. So we thought this could be a great example to create a global benchmark of an SDG indicator. This concept of using the same data set, applying it to every country, how do countries compare? It is our hope that this will increase participation and a opportunity to share the results totally transparently. So we do everything in the open on GitHub. and the methodology can be compared, and the data can all be accessed. If a country looks at their the number that we generate and disagrees with it, it's a great opportunity to say, well, what data do you have that's better? Can we contribute towards increasing the accuracy of this by doing this global benchmark? And some of the challenges are definitions, data quality, and methodology. I'm going to go into each one of those. So when you probably first heard that, what is urban versus rural? How do you define that? How is GRUMP defining it? There's controversy on this. How you define these boundaries will obviously impact the score. So countries may have more incentives to define it in one way or the other compared to other countries. And so it's important to have this universally agreed upon methodology for defining urban versus rural. What makes something all season? If a road is super poor quality and dirt, and there's hurricanes, typhoons, it's washed out for half the year, that's not really going to provide access when people need it. So some concept of a road that is actually accessible all season. And then can we actually rely on OpenStreetMap tags? This is a volunteer created data set, and people do not always update the data sets in the exact same way. Is there a way around that? So this is a screenshot from the final tool. It's available at rai.azavea.com. That stands for the Rural Access Index. That's basically another term for 9.1.1. We generated this in partnership with an organization called Cardno. They were interested in basically mapping road construction progress in Africa. They were responsible for actually building roads and wanted to develop a framework for measuring and monitoring progress. And so we were able to partner because we had very similar goals. For every country, you can go ahead and click on that country and get a bunch of statistics about the percent of the population served, the total population, rural population, road length. And then for 3 countries, there's actually this ability to compare this methodology used with open data and in-country data. And so how do the results compare when a country is providing the data versus these open data sets? And in our analysis, the results were actually quite similar. This is really promising for the open data approach. So the analysis, how did we actually do that? You might be thinking, oh, there's only 3 data sets. The methodology is pretty clear, distance to road. But when you're doing this globally, you're starting to talk about hundreds of gigabytes of data, something that cannot be done on a personal laptop, something that requires cloud computing. And so Azavea is really well positioned to do this type of big data analysis. We have a suite of tools that prepared us to accomplish this task effectively. GeoTrellis is an open source library for doing big data raster processing primarily, although increasingly doing vector analysis. It leverages Apache Spark, which is an open source framework for doing distributed processing on big data sets in a cloud-based environment. VectorPipe is a library built on top of GeoTrellis for working more particularly with vector data. And then Mapbox vector tiles are a easy way to visualize large vector data sets, which is what we produced for the output of this product. So going really deep into the analysis is a little beyond the scope of this talk. I could certainly spend an entire talk going much more deeply into the actual analysis, but I'm going to go over a handful of slides that kind of show the overall process without getting into any code snippets or details. Because we generated this all programmatically, it runs globally in about an hour. And if the data set gets updated, one can imagine running this daily, weekly, monthly, whatever cadence, and having a super up-to-date, accurate visual assessment of the world based on these open data sets that are continuously being updated. So we clip the geometry of the world into a number of grids, break up the population data sets and the road data sets into these grids so we're working at a manageable unit. And then we buffer each of the geometries 2 kilometers, get the centroid, and reproject so that there's a consistent kind of geospatial component, and then take a summary of the raster data, aggregating it to each country. So what is next with this work? I have some open questions. We really started doing this work late 2019 and published our analysis in early 2020. So from my perspective, this is still relatively new. As far as I know, there's no one else doing a global analysis at this scale. And so we're still engaging folks, having conversations, seeing, are we making assumptions that are not accurate? Can this analysis be expanded? So yeah, some of the open questions. Is global public data good enough to measure the SDGs? From our first impression, the answer is yes, but we're still having conversations about that. Then there's this concept of authenticated versus validated data. So data that's generated by volunteers, citizen-generated data, is potentially, you don't know, is it accurate? Do people have good intentions? And so I think doing comparisons of authenticated data with open data until you have a sense of kind of the accuracy, how do the results compare? I think there needs to be more work done into comparing the open data versus the officially recognized data. And then there's a question of what role do private companies have in SDG monitoring? A lot of the data processing is typically done by countries, but as I mentioned, some of these national statistic offices are kind of strapped, overwhelmed with their additional work. Is there a way for the private sector to offer their expertise in kind of big data, working with different data sets, kind of cutting edge solutions that might not be available to the public sector? So we're still trying to figure out exactly what role private companies have. How might you be able to get involved? Well, the SDGs are so dang broad that there's a chance that your work is already aligned with one or more of the SDGs. So I think big part of the value of the SDGs is creating the shared framework for talking about how to measure success and progress towards these very ambitious goals. And so I think the more people that are familiar and understand the SDGs, the better for increasing the overall utility of the framework. I think learning about OpenStreetMap or other tools like it, probably most people contribute to Wikipedia or have at least used Wikipedia, but there's also kind of version that's similar, but for maps. And so knowing its limitations or possibilities, I think it's really helpful. Contributing to it is a good way to learn about it. And then reading up on the SDGs. Do you know of open data sets that might be helpful? So I'm quite excited about this. The concept of a decentralized citizen-generated data that contributes to measuring the progress of the whole planet. To me, that is super exciting. I think we're only at the early stages of it. The technology is still developing, but I think it's there based on our experience. And then here are a bunch of resources. So resources on the publications I referenced earlier, and more information on SDGs, funding opportunities, things that I've learned over the course of the last 6 or so months of working on this project. And then access to the GitHub repository, which shows the work that we did, and links to visualizing the demo. So I love to hear from anybody who is either working in the space, has feedback, criticisms, critiques, wants to give kudos. I think this is a really cool analysis. So you can reach me at my email, or that's my Twitter handle. That is everything that I have today. Thank you for the opportunity to share with you.
Awesome. I'm going to come back in for some questions here. So the first thing I have is what are your biggest epiphany moments when doing this type of analysis and building this type of product out? What were the things that surprised you the most?
Yeah, that's a good question. I really enjoyed this project. I think that, honestly, one of the coolest moments was taking it from the software development team, running the actual analysis, and then sharing the results with the design team. So this is a static site. There's no running server. There's no databases. Vector tiles and pyramided PNGs allow us to do everything in this like super efficient kind of project management perspective. So we just can update these files on S3. We use Amazon Web Services pretty extensively. And so when we passed the data analysis, which took like several months, to the designer who was able to prepare this in like a couple days, I was pretty blown away because there's a lot of data here, and how quickly the project came together was really impressive from a kind of software perspective. think you might be muted. I can't hear you.
All right, there we go. I have a bad habit of doing that live. So let's. So I want to know what's ahead with this. I actually had a chance to peek at the website where you're giving your presentation and the product itself. You're able to output as a Excel file, the data says an Excel file. Any hopes of getting outputs as GeoJSON files? And aside from that, I know you only go down to the country level, but if folks want to go down to more regional or smaller regions, is there any chance to expand that to refine the score?
That is a great question. Both of those are things we talked about with our project funders, and that's sort of like a phase 2. Both of those are super possible and even not super challenging. It wouldn't be hard to actually convert the Excel export to GeoJSON because it could just map it to countries. And then in terms of aggregating it to smaller like subnational boundaries, that is totally doable. It's just like a matter of time and focus. Is anyone asking for it? So happy that you asked. The answer is absolutely yes, but we have not done it yet. Just kind of funding limitations.
Why 2 kilometers? Why not more than that? Why not less? Why 2 kilometers? Why is that the number?
Yeah, that's a good question. This indicator was developed like 15 years ago. Initially, some version of it, I think around 2006, and they felt like 2 kilometers was kind of a comfortable amount that you could walk in less than an hour. That wasn't like a whole day's journey. So if you're trying to sell something at market, you could walk 2 kilometers, and the burden is like, yeah, it's manageable. In kind of a morning, you could do a round trip. So there was some cutoff, but they felt like that was the right balance between close, but also not too close.
No, that makes sense. Does it make sense to also like based off of, you kind of hinted at this early in the presentation, but based off of certain level countries' development, not just of rural roads, but just the kind of organization structure of the country to kind of refine that scale a little bit more? For example, maybe in the United States, it makes more sense to do 5 kilometers instead of 2 kilometers. And in other countries, 2 kilometers makes total sense because of the amount of terrain hardships or organizational structure of the infrastructure overall.
Yeah, super good question. I think you're getting at this sort of tension within the SDGs, applying the same indicator to every country when kind of the landscape, the geographies, the histories are super different. What if you have a road that is on the other side of a river? The analysis that we took, the analysis takes no consideration of river crossing into account. If there's no bridge there, that road does absolutely nothing for you. But there's this tension between doing an analysis that's doable. And so what percentage of people are affected by that? In some countries, it may be super high, and in some countries, it may be 0. And so that's why there's a lot of discussions around reaching consensus around how to define this. There's definitely going to be critiques. It makes more or less sense in some countries over others, for sure.
Understood. So if you were to use other data sets to correlate and build more detail to this, what would you want? What's your wish list?
I think one of the biggest limitations is probably the global urban-rural classification data set. GRUMP is awesome, but it's a little bit outdated. There is talks of developing a better urban-rural data set that is based on population density. And so no one has actually just generated that for the world, so it's not available yet. It's something we're talking about doing, but trying to find the right time and place. So I think having a better, more up-to-date measure of the urban-rural divide would really make this a lot more useful.
Makes sense. Is there any type of pattern you've seen in terms of where the roads and where these where the results lie as it relates to things like telecommunications or other infrastructure that exists?
That is a great question and something we did not super look into, if I'm being totally honest. So in general, areas that have higher population are for sure going to have higher telecommunication network systems. Like, I mean, wealthier areas, that's going to be correlated for sure. But that is something we did not look into on this project.
No, I was just curious because regardless of the higher layers of telecommunications, rural access might determine what type of telecommunications is available as well, which brings in another method of just what infrastructure is in reach of those individuals. So I thought that was a fascinating thing. I've looked on some of this stuff on a micro level, but to do it on scale, what you have done, that's pretty impressive. And I love to download the global RAI data and take a peek at it myself. So love what you guys did. This is an impressive data set, and thank you for coming on with us and sharing this with us.
My pleasure. Thank you for the good questions, and we look forward to hearing from more folks in the future. Hope everyone is doing well during these crazy times, and yeah, hope you have a good rest of your Friday.
Awesome. Well, this is Ross Bernet with Azavea. Is that pronounced that right?
Actually, it's Azavea, but
Azavea. Very good. Yeah. Calculating rural road access globally using open data sets with open source tools. I'm Adam Simmons with Project Geospatial, hosting the Geospatial Frontier Virtual Technology Fair. Thanks everybody for joining us.